Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how you can multiply polynomials. Now, there are lots of different ways we can do this, and when it comes to polynomials, there's actually different methods that we end up using. Some people use something called a matrix method. Some people use something called the distributive property. Some people use an acronym that works sometimes, but not always, but it has that same idea. So I'm going to go through and show you a couple of the different ways that you can do it, and you can decide which one you like best. Now, to start with these, you've done a ton of distributive property already. So we want to just revisit that. Now, the new thing that comes with the distributive property is when it comes to multiplying, sometimes we're going to multiply things that both have x's. So what do? So go ahead and take a look at question number 4 here. Now, usually when we did the distributive property, we do the first times the first and then the first times the second. Now, that's still going to be the case. However, when it comes to multiplying these polynomials here, what we're going to end up doing is we're going to multiply them together. So when you multiply anything that's just 1 times another, so like the 6x squared and this negative 8, you're going to start by multiplying the outside numbers. So those are the big numbers, right? We call them the coefficients. Okay, so we're going to start by multiplying the coefficients. After you've multiplied your coefficients, what you're going to end up doing is we're going to add the exponents. Okay, those are the little numbers. Now, if there's no number there with our exponent, for example, with this negative 8x, what we're actually going to end up doing here is you're going to end up putting a 1 right there. So it's a negative 8x to the first. So as we go to multiply these, we want to figure out what that equals. So we've got 6 times negative 8, which gives you a negative 48. Then we're going to add the x's. So I've got 2 x's in the first term, 8 x's or 1 x in the second term. 2 plus 1 is 3. So I get negative 48x to the third. Then as I go to multiply those other ones, so our 6 times 4, we end up getting a 24 x squared because that x squared still comes with it there. Now we want to make sure we write these in standard form. So in this case, you see that we've got our negative 48x to the third plus 24x squared. The x to the third comes first before the x squared, so we are good to go there. Now, that's how you can do it with the distributive property. We have a whole video that revisits how to do that. So if you need to watch it, we can definitely watch again, and you can find it on Canvas as well. Now, what we're going to talk about is what happens when we're multiplying polynomials, but they're not 1 times another. So you can kind of see here with question number 9, we've got 2 pieces, this m and this plus 2, times this 8m plus 2, which also has 2 pieces. The distributive property was 1 times 2. This one is 2 times 2. So there are 2 different ways to do it. Option number 1 is something that people call foiling. Really, FOIL stands for first, outside, inside, last. Now, that's kind of a dated term, but really what it's saying is I'm going to take the first number, I'm going to multiply it times all of the second ones. So m times 8m gives me 8m squared. M times 7 gives me a 7m. 2 times 8m gives me a 16m, and 2 times 7 gives me 14. Then I just get to go and combine those pieces together. So I've got 8m squared plus 7 plus 16 is 23m plus 14. Now you can see how we end up with that answer. And this is an awesome way, and this is kind of a typical way. However, for some people, this way of just doing it in your head is kind of difficult. So another way that I found that works fantastic is called the matrix method. So what you do is you're going to draw a box. Make sure you have enough space to write in. You don't want a small box. Now we want to split our box up based on what we have. So because our first polynomial has 2 pieces, we're going to split it 2 pieces this way. Our second one has 2 pieces, so we're going to split it into 2 pieces this way. Then we're just going to label it. So this is going to be our first polynomial here. So I've got my m and my positive 2. Over here, I've got my 8m and my positive 7. So then what we get to do as we're multiplying these is we will just multiply the 2 things that make up the box. So we're going to do m times 8m, and that gives me 8m squared. Then we would do m times 7, which is 7m. We do 2 times 8m, which is 16m, and we do 2 times 7, which is 14. Then we can go and write them out, and you'll notice that as we write them out, we end up getting exactly what we had here. And then we can go ahead and combine those together. So as we are looking at this here, and we're combining those pieces together, and we're figuring it out, you can see how we both ultimately end up here. So as we go through these next 2 questions, I will show you both methods, making sure that you can choose whichever one you like, as long as it's going to work for you. So let's go ahead and take a look at the next one here. Let's look at number 11. So I'm going to set up my box here. Because I've got 2 here and 2 here, I'm going to split it up into a 2 by 2. So my first one is going to be a 3r and a -3. My top is going to be 5r and a -1. Now, if you're not doing the matrix method and you're multiplying, you're going to do it the same way. So 3r times 5r, well, that's going to give us 15r squared, which goes into both of these. Our 3 times -1, or 3r times -1, which is also this rainbow, gives us a -3r. Our -3 times 5r is going to give us a -15r. And our -3 times -1 gives us a +3. So as we go to write all of those out, we then can combine together the ones that look like. So there's only one r squared. So we've got our 15r squared. We've got 2 of these r's. So -3r minus 15r is a -18r. And then you've got one constant, so +3. So you choose which way you like. You can either just show your rainbows here, or you can go ahead and draw this box. I really like drawing that matrix or that box because it helps keep my numbers organized there. Now, the awesome thing about this is we can use this same method even when there's more than that many. So I want you guys to go all the way to number 17. Yes, there are 3 pages on this one. So as you go and look at number 17, we can do this one the exact same way. So if you're going to do the matrix method, we're going to draw our matrix here. Now I have 2 the first time, so I'm going to split it into 2, and I've got 3 pieces the second time. So I'm going to split that one into 3, and then we can go ahead and write them. 6n, +7, 8n squared minus 8n plus 5. Now, if you have both of those written, which is awesome, you can also do it that other way with our distributing. So we would do our 6n times 8n squared, and you'd write that number down. I'm going to put it in the box here, but you can see how we would do it. So 6n times 8n squared is going to be 48n to the third. Then we've got 6n times -8n, which gives us a -48n. You've got your 6n times 5, which gives us 30n. You've got 7 times 8n squared, which is 56n squared. You've got 7 times -8n, which is -56n. And you've got 7 times 5, which is 35. Then we can write those all out and combine them together. So as you multiply it with the little rainbows or with the box, regardless of how you do it, you should end up with 48n to the third minus 48n squared. Sorry, this one up here should be an n squared. Plus 30n plus 56n squared minus 56n plus 35. Now, maybe you're good at the mental math. I definitely pulled out a calculator to figure these things out. But as we're doing it, we have no other n to the power of 3s. So we are going to write our final answer with 48n to the thirds. Now I've got 2 n squareds. I've got a -48n squared term and a +56n squared term. So -48 plus 56 gives us a +8n squared. Then we have our 30n and our -56n. Those add up to be a -26n. Then we are left here with our +35. So you can see how as we do these and you set up that little matrix, you can make the matrix as big as you want. So if you multiplied trinomials, so 3 pieces by 3 pieces, you would just make a box that's 3 by 3. If you multiplied a 4 by 4, you'd make a 4 by 4. If you multiplied a 2 by 7, you'd make a 2 by 7 box. But they all end up being the same, where every piece gets multiplied by every other piece. So if you have any questions, don't hesitate to ask, but that's how you can multiply polynomials.